Hi everyone, welcome. This video goes over the RBasics script that accompanies the RBasics and data structure slides and video. So a few things that I want you to notice here. First is that I'm in my DAX 601 project. So when I open RStudio, because this is the last project I was working in, it automatically pops up. You see I have a lot of different folders that I've worked with, a lot of different projects. If I want to transfer between them, all I do is just click this from the list. So it goes ahead and it switches to the correct project. Now let's say I wanted to open this in a different way. You can also navigate to wherever your DAX 601R project folder is saved on your computer. So I like to have mine on my desktop. You might like to have it elsewhere, but you can go ahead and navigate here and then click the gear to set as working directory. So make sure that that working directory is set before you get working. If you ever want to check, is my working directory what I want it to be? All you have to do is type get working directory, and indeed we are in DAX 601. The next thing that you might notice is that this text is a little bit larger than what I'm guessing yours is. If you want to make your text larger as well, what you can do is click on view, and I'll show you the actual size. You see how it's a lot smaller. Click on view, and then zoom in a few times. That way it becomes more legible for the video, and it might be a little easier on your eyes as well. Your next question could be, well, why am I using an R script for you when you are asked to use Quarto documents for your challenges? The reason is simple. I just want you to get exposure to a different type of writing code. So the code itself is the same, it's just a different document type. And I just want you to have experience with both. So for most of my examples, I'll be using R scripts, but I'll be asking you to use those Quarto documents. And you can see here that it's actually quite similar to Quarto. Really, the main difference is that there's not the markdown text. There's not the fancy text that we can edit in between our code chunks. But we see a very descriptive title here at the very beginning, followed by an author, and then always the date and the project. So I like to label all things to do with this course as DAX 601, and then I like to label whenever it is that I'm writing this document. So in our case, summer 2025. Another thing you notice is that there are headings, and there is a table of contents here that you can click on. So to create a heading, just type in a few hashtags here, which is a code comment, have a descriptive title, and then I like to have a horizontal line here, which is just a bunch of dashes, and then it pops up here. It's a nice way to break up your code, make it a little bit more manageable in those different sections. So our first task when we're looking at an R script or we're starting a project is always to install or load the packages that we need. So as I mentioned in our last lecture, R is built on open source packages. So instead of having to run all of the background code that goes into a function, all we have to do is load that function with whatever package it is. So to install a package, for example, tidyverse, which is the primary package that we use, all you need to do is type install.packages and then put whatever the package name is in quotes. On my computer, I click Command Return because I have a MacBook, and it installs right here, and you can see that it's done when it says the downloaded binary packages are in, and then that file path. Another way that you can run code is you can click on the line and click Run up here. And we see here what I've done is I've used the library function to pull in tidyverse. So you only have to install a package once, and I thus recommend that you actually run your install packages line in the console instead of your script. That's because you don't need to keep rerunning this line every time you run the script. You've already done it. It's already there. It's in your R folder. All you have to do is instead run the library. Now, why do we have to run the library? If you look over here, there's tons of packages that you're going to end up downloading or that you use, and we don't want all of them to be essentially taking up memory at once. So what R does is we just say, hey, I want you to open up this one right now while I'm working. And when you close a document, you have to run the library again when you open it back up. So oftentimes you'll have code, you open it back up, oh no, it's not running. The reason is most likely that you haven't run the proper libraries. Another way for you to install a package is to go down here in your bottom right quadrant where you find your files. click on Packages, click Install, and you can type that in right there. So we have our packages installed, we have them loaded through the library function. Now let's talk about commenting code in our next section. So I know I talked about this a lot in the last video. The overarching message is that please be descriptive. And this is really truly to help you. The idea of commenting code is so that your code can be reproducible and also so it helps you and whoever your audience members are. So for you, I've had this happen to me many, many times as I've learned to code. I might have one assignment that, for example, asks me to merge data sets. And then I encounter a problem with merging data sets later on, maybe in a different class or a different project. And I just go back and I refer to that original project. I pull that code. You're going to be copying and pasting a lot of your own code as you go through the DAX program or as you continue to learn R. And the idea is that when you comment, it's very easy for you to understand exactly what it was that you were trying to accomplish in that code. It's also helpful for your audience members, in this case, your instructors, because we can understand the logic of what you were trying to accomplish. It's easier for us to award partial credit or to gauge if you understand what exactly it is that you were trying to do. So anything that is behind that hashtag, anything that is gray like this, that is not going to be read by R as code. It is read as a comment and essentially it is ignored. So we will be looking to make sure that you are commenting your code regularly. And here's an example. I have a variable. So I'm assigning hello world to X, and I have a description that I'm assigning a string value. And this actually is not a very good variable name because it's pretty vague. It's just X. But what I've done is I say, hey, X, I'm assigning hello world to. I'm assigning the string value. X represents this. And when I run this line, again, I can click Command Return, or I can highlight it and click Run. We see that it pops up in our global environment. What this means is that for every line after this code, we can refer to X, and R will know that it means hello world. Now, let's say this gets busy up here. You're trying around different variables, you've run a lot of code, you maybe need to start over, or you just want to clear this. Very easy, just click on this. And all you have to do to get that variable back in your global environment is to run the line again. Here's a better descriptor, empty list. Indeed, what we're doing is creating an empty list, so this is a much better variable name, but we see the variable name, the assignment, and then the value. And we see this pops up under data in our global environment because a list is a data structure. We can do the same thing with functions. So for example, list is a pre-built function. You can write your own functions, and we'll get to this in the second half of the semester. Here I have a very simple function called add1 that takes an input of x and returns x1. Don't worry, I don't expect you to understand how this works yet because we're not there. But what I want you to pay attention to is the fact that I've clearly commented what this is doing. And when I run it, it also shows up in my global environment. And then I run this function with an argument or an input of 1, and I see an output of 2. As I emphasized in the previous slides, naming nomenclature is really, really important. And here, let me go ahead and uncomment this. Immediately, we're going to get an error. So this X means that there's an error right here at line 28. And the error is that there's a space. So here it says unexpected token names, unexpected token, and then the assignment operator. R doesn't know what to do with this space. Any space like this, where it's like, wait, there's some characters, what is this? It doesn't know what's going on. It's not going to be able to recognize that name. Another thing that's wrong with this is that it has capital letters in it. I do encourage you to stay away from capital letters solely because R is case sensitive. So pet names with lowercase versus uppercase letters, very different things. But if it is your preference, that's fine. That's just a general thing. Make sure that you remember that this is case sensitive. And so let me go ahead and run that line. We see pet names Ivy. And then blah. Why is this a bad name? Again, this is not descriptive. I don't know what blah means. And then same with pet names. This is the most ideal name because it's specific. So it's not just names, it's pet names. And again, this would be referring to probably a vector of strings with someone's pet's names. Moving on to data types and data structures. So, more variable assignments just to give you some practice. Here I have a very descriptive variable name, logical var, that makes sense, and I'm assigning it with true. So your logical options are true or false. Here we see this pop up in our values list in our global environment. And if I wanted to check that class, I use the class function and it pops up with logical down here. We can do the same thing with assigning a numerical variable. So again, 718, that's numerical, and the class pops up as numeric. Now let's say we don't want that variable to be numeric. Let's say that we actually want it to be a string for some reason. You can easily change that using the as.character function. So that's part of the as.type function that we talked about in the previous lecture. I have, again, a descriptive name. I'm saying numerical to string, and I'm just using this function. I'm feeding it numerical variable. And once I do that, we see numerical to string up here. We see that there's now quotes around 718. When we check the class, we see character. Now, let's say you're a little confused about as character. That's where you can do something like type in the question mark as character, and we see these start popping up. So the things that you can search. When we run that line, here we have all about that as character function over in the help documentation. So I encourage you as you're learning these new functions, I never require you to memorize them. You'll understand them the more you use them, but this is a way to learn more about them. Is just type in question mark, whatever the function is, and see what the documentation tells you. Moving on to vectors. So here's an example, a simple example of a vector. Here we used the C function. C I think of as combine. We have a descriptive name, so Larry pet names. These are all pet names that I've had in the past, and we create that vector. We see it's over here. What we find in the global environment is that it tells us that is of type character. There are 5 elements, and then it starts to list them over here. I can also view this vector just by doing this, just by typing out that name and running it. And again, we can check that data type right here. I can create a numerical vector with ages, view it like that, check the class. And here's an example of coercion. So remember, vectors have to have all the same data types. So it all has to be all strings or all logicals or so on. And we see here that this vector has a variety of data classes in it. And so if we look over here too, this is called vector coercion. It's automatically going to be class character because it has a string in it. So usually if there's a string, everything is going to be coerced into strings. Now factors. Here I'm going to reference the specific types of animals that I used in Larry pet names above. So I'm starting with just a regular vector with a list. So I've got rabbits, fish, snails. At one point, I was pet sitting a guinea pig when I originally wrote this code. And now let's print out those values. So I see it's just a regular vector. We look up here, animal type, character. You could also type class. But my house also has another animal type, and that is shrimp. So I have a few fish tanks. I've got snails, fish, shrimp. But if I looked at the animal type vector, you're not going to realize that there are more options for the animals in my home just based on what I have here, because I don't have any names for my shrimp. And so what I can do is use the factor function. And what I'm doing is I'm converting the animal type to factor, and I'm making the possible levels explicit. So here I'm naming, okay, I have rabbits, I was watching a guinea pig, I have a fish, I have snail, I have shrimp. And I use factor to make it explicit what my different options are. So let's go ahead and run that. Now, when I look at animal type factor, it also tells me what possible levels there are. And this can be helpful. So let's say we are tracking the number of pets I have over time. And let's say in January, I have no shrimp, but in February, I have 2 shrimp. Now I can show that change. Data frames are a very, very common data structure that we will be using frequently in this class. In fact, in Challenge 2, you will be asked to read in a data frame in Excel format. And so what I'm going to do here is I'm giving my data frame a descriptive name, and I'm using the data frame function to specify what those columns should be. So I have two different variables. I have name, which is going to be the Larry pet names, and I have type, which is that animal type factor that I just created. And when I open that data frame, here I have what I was referencing for the atomic indexing in the slides. I've created a data frame. It has 5 rows and 2 columns. I could create a list, another data type. We don't use lists that much in this class, but again, it's just good for you to know that they exist. Just like the data frame up here in my global environment, which if I click on it, I learn more. If I click on it like this, it opens up here in a separate tab. Now we can see also my example list. And when I click on it here, there we go. It pops up. And you can also embed lists within lists. So I could make this, for example, a list within that. This is the missing data example that we discussed in the slides, so I won't belabor it too much, but remember that R considers it labels missing data with NA, and that is different from NA within quotes because that would just be considered a string. So if I want to check if there are NA values in my data, I'll use the isNA function. And then if I try to calculate the mean, for example, it's going to tell me that it's just NA. So anytime that mean or mode or max or min or any of those sort of numerical functions encounter an NA, they say nope, and they just output NA. Like they won't do the rest of the calculation. And so if I want to do the calculation ignoring those NA values, what I do is I pull in the argument of na.rm equals true. And so what that's telling the mean function is just please remove NA values from your computation. Now here we see mean is a function as I'm using it. So mean and then the parentheses indicate that it's a function. And these are arguments. So the first argument is I'm telling it exactly what data it should be calculating the mean for. So NA example is my vector. And then the second argument is this na.rm equals true. So argument 1, argument 2, I could set na.rm equals false. Oh, that's what it's already set to. So it's automatically set to. It's not going to do that unless you explicitly tell it to. But let's look at mean here. Mean, and you can see the arguments over here. So the first thing that mean is looking for is x, that R object. Again, in our case, it's a vector. It could be a specific column in a data frame, and so on. And then you can see these different argument options. So trim, let's say that I wanted to adjust the fraction of what's included, what's computed, I could do that. Here we see that na.rm, which you're going to use a lot with any sort of statistical calculation. It tells you exactly what that argument can do, and so on. There's other arguments, and what you would do is you would want to just look this up online to find more in the R documentation. But that's an example of using na.rm. That's an example of arguments. What's cool about these functions, again, they're pre-made, they come in the packages that we download, is that there's lots of arguments that we can adjust them with. Let's move on to, again, the accessing specific elements of a data structure. So sometimes you want to just pull out a specific column or even just a specific cell. And what you want to do is you use these square brackets to indicate what elements you want. So for example, in animal type, I've pulled out just rabbit. In the data, and that's just the first index in that animal type vector. Again, remember our index is at 1. So each position in that vector or that data frame is, 1, 2, 3, whatever position it is. Now let's say I just want the George cell in Larry Pets. I'm going to ask for the first row and the first column. It'll show me that. And looking back to the Larry Pets data frame, right, we have George row 1, name column 1. There we go. George is that cell value of row 1, column 1. If I want all rows of only the first column, we do that. We say, okay. all rows, I'm not going to indicate a row, and then just column 1. And then if I want only the first row of all of the columns, I just say, "Okay, row 1, all columns," by not indicating anything. If I want to access a specific column, I can also just use this money sign. So I type out the data frame name, and then I pull in that column. So here, this does the same thing. Whichever you're more comfortable with is what you should use. We can also subset with logical vectors. So again, I'm using the Larry Pets data, but I'm going to expand it to include a numerical column. So here I'm creating a vector of pet ages. And again, a vector, we use C, that function, and we list out their names at the time. What I'm going to do is create a new data frame. So I have Larry Pet's age just to indicate that it's something different. We use the data frame function. The name variable will be my pet names, that vector. The type will be the factor that I created earlier. And then age is that pet age vector. So let's do that. And here we see a third column added in. Now let's say I want a subset. I only want the aquatic pets. I can also use the subset function instead of going through with the atomic indexing. What I could do is just I first type in the data frame that I want to subset from. I'm going to say type is equivalent to fish or type is equivalent to snail. So you have to type out type for both. You can't just do type equals equals fish or equals equals snail. It will throw you an error. We're going to do that. And now we see that we've selected only the fish and the snail. And let's say we have more than just fish or snail. Let's say we have lots and lots of options that we want to pull from. What we can do instead is use this percentage. Yes, I remembered the word for this second video. Percentage in percentage. List out a vector of the strings that we want to include. And that does the same thing. So that's it for our basics. We've explored commenting. We've explored some code style in terms of naming nomenclature. We've talked about the different data types and how they can be structured. And in our next video, we're going to explore reading in external data. So reading in things like CSV or Excel files.